Okay, so in terms of zero exponent, the rule is that any base except for 0, of course, 0 as a base is not allowed. Any base raised to 0 is always equal to 1. Okay, so now let's have some example where we could apply the zero exponent rule. As mentioned from the zero exponent rule, it is stated there that any number raised to 0 is always equal to 1, but except for 0 itself, or 0 as our base. So now we have here 4 raised to 0, which only means that it is equal to 1. 1000 raised to 0, which also means that it is equal to 1. And how about for our next two examples? So even though these are two coefficients, we have the numerical coefficient 3 and the variable x here, they are still considered 1 because of the grouping symbol. And its exponent is still 0. So therefore, we can say that 3x quantity raised to 0 is equal to 1. Same way with 22yz quantity raised to 0, since this is in one grouping symbol and they are raised to 0. Even if we follow our power rule, right? So meaning we have to multiply 0 to the exponent of our coefficient. So we have 22 raised to 1 times 0, y raised to 1 times 0, and z raised to 1 times 0. Even if we do that, we would still arrive with 1 because 22, it will become 22 raised to 0, y raised to 0, and z raised to 0. So instead of doing that, you just have to simplify that as 1, or 22yz quantity raised to 0 is equal to 1. Okay, so now let's have another set of examples. But in here, I'd like you to understand where specifically do we need to apply the zero exponent rule. Is it for all the variables or coefficients, or for a specific variable alone or coefficient? So now, let's try to do the first example. On our first example, as you could see, 3ab raised to 0. It only shows that our b is the only one that is being raised to 0. How about for 3 and a? So, since we don't see any exponent, it's understood to be 1. That's 3 raised to 1 and a raised to 1. But again, we do not write them anymore. For our first example, we have 3a, then b raised to 0. We could simplify that following the zero exponent rule, and that is equal to 1. So now, let's multiply 3a times 1 will give us 3a. Now, let's move to our second example. We have here 3 times ab quantity raised to 0. So in here, we could see that the variables a and b are grouped inside a parenthesis. So in here, it's understood that the 0 exponent here is applicable to our a and b since they are in a grouping symbol. And 3 has an exponent of 1. So now let's simplify. 3 raised to 1 would still be 3. And AB, quantity raised to 0, will now become 1. So now 3 times 1 will give us 3. For our third example, this is actually similar to the one I have shown you from my first set of examples. So as I have explained there, that since 3AB is in a grouping symbol and it is raised to 0, we can consider it as it is equal to 1. So even if you apply the power rule wherein you have to distribute the 0 to by multiplying the exponent of 3a and b to 0, so we would still arrive to an answer of 1. So let's try. So we have 3 raised to 0, a raised to 0, and b raised to 0, because 0 times 1 is 0, 0 times 1 again for a is 0, and 0 times 1 as the exponent of b is equal to 0. And even if we simplify it individually, that would still give us 1 times 1 times 1. And again, that is still equal to 1. For negative exponent rule, all you have to do is to get its reciprocal, or if a factor in the numerator or denominator is moved across the fraction bar, the sign of the exponent is changed. Just like here, we have a raised to negative 1. So as you could see, when it has been moved to the denominator, the exponent becomes positive. But if ever your negative exponent comes from the denominator, then you just have to put it on the numerator for it also to become a positive. For our first example, we have 2 raised to negative 3. As stated in negative exponent rule, all we have to do is to make our negative exponent a positive, we just have to get the reciprocal of its base. So we have here 2 raised to negative 3. So in getting its reciprocal, if it's on the numerator, we just have to place it on the denominator. And if the one that has a negative exponent is on the denominator, then we just have to move it on the numerator for it to change the sign of the exponent. So let's do it for 2 raised to negative 3. So again, to make it positive, all we have to do is to place that on the denominator. So that will become 1 over 2 raised to 3. Then, since 2 raised to 3 could still be simplified, which means 2 times 2 times 2 is equal to 8. Therefore, our final answer would be 1 over 8. Let's do the same process for x, y, quantity raised to negative 5. Here, we have a grouping symbol again, meaning x, y is considered 1. And both of them has a negative 5 exponent. So again, following the negative exponent rule, we have to make this one positive by placing this one on the denominator, since originally it is on our numerator. So that will be 1 over x, y, quantity raised to 5. Take note, I did not remove yet the grouping symbol because what I wanted first is to make our exponent from negative to positive. Then, following again the power rule, meaning we have to distribute the 5 here by multiplying it to the exponent of x and y. Therefore, that would be 1 over x raised to 5, y raised to 5. Now, let's move to our third example. So, we have here 1 over 3x, quantity raised to negative 4. As you could see, our given is a fraction. And again, all we have to do to make our negative exponent positive is to get its reciprocal. So meaning the 3x here must be placed on the numerator and the 1 here must be placed on our denominator. They must be interchanged in position to make our exponent positive. So now we will get 3x over 1, quantity raised to 4. Again, same with our previous example, I did not remove the grouping symbol because as you can see, the exponent 4 here must still be distributed to our coefficients inside the grouping symbol. Since 1 raised to 4 would still give us 1, therefore, I think I could remove that already. So now, all I need to do is to distribute 4 by following the power rule. Now, I will get 3 raised to 4 x raised to 4 because I multiplied 4 times 1 and that will give me 4. 4 times 1 as the exponent of x, and that will give me also a 4. Now, I have to simplify 3 raised to 4, and that will give me an answer of 81 x raised to 4. Now, let's move to our last example. So, we have here 2b over 3a, quantity raised to negative 2. First, make your negative exponent a positive by interchanging your numerator and denominators. So, we have to put 3a on our numerator and 2b on our denominator. But again, they should still be inside the grouping symbol. And now, since we interchange their positions already, our exponent now will be a positive 2. Then, following power rule, we must distribute it to all the exponents. We must distribute it by multiplying the 2 to the exponents of our coefficients inside. And that will give us 3 squared, a squared, over 2 squared, b squared. Again, 3 squared and 2 squared could still be simplified. Therefore, we must simplify them and we will get 3 squared, that is equal to 9, a squared, over 2 squared, and that is equal to 4, b squared. And that's it. Therefore, our answer will be 9a squared all over 4b squared. So now let's have another set of examples where we could apply the negative exponent rule. So here we have 2 raised to negative 2 over 3. Again, we should only apply the reciprocal when we have a negative exponent like from our numerator, 2 raised to negative 2. So again, for it to become positive, we must place 2 raised to negative 2 on our denominator. So that will give us 3 times 2 squared. Now, what will happen on our numerator? Since there's nothing left on our numerator, again, it doesn't mean that's 0. That is actually equal to 1. Okay? So, we have to simplify our denominator since we have 2 squared and we have to multiply it by 3 afterwards. And that will give us 1 over 3 times 2 squared is equal to 4. Now, let's multiply 3 and 4. And finally, we have 1 over 12 as our final answer. So how about for our second example? So I'd like you to take a look closely on which of the variable has the negative exponent. As you could see, it's the y who has the negative exponent, and it's not the x. Therefore, the one where you should apply the negative exponent rule is only for the variable y. So it only means that x must be left on the numerator, while y raised to negative 5 must be placed on the denominator for our exponent to become positive. So again, y raised to positive 5. From negative 5, it becomes positive 5. And that's it. That will be our answer. Next, we have here 1 over 3x raised to negative 4. Again, take a closer look on this, as we all know that the negative 4 here is only the exponent of x and not the exponent of 3. But sir, what is the exponent of 3 there? So the exponent of 3 there is actually 1. The same way with our x a while ago. And both of their exponents are positive. That's why we don't need to get their reciprocal anymore. So from this example, the one that should we reciprocate is x only. So x must be placed from the denominator going to our numerator so that negative 4 will become positive. So now let's do that. So again, x raised to 4 all over 3. 3 must be left on the denominator because it doesn't have a negative exponent. And that's it. So how about for our last example? We have 2a raised to negative 1, b raised to 2, all over c raised to negative 2d. So again, please be careful about the negative exponent. Okay? So we have a negative exponent for the variable y, therefore we must move it from the numerator going to the denominator, and same with our variable c. Since it has a negative 2 exponent, so it must be moved also from our denominator going to our numerator. Sir, what are we going to do with the rest? Okay, so we don't have to do anything with those with positive exponents already. They must stay in place. So now we have 2b squared, since both of them has a positive exponent and we don't need to move them. The same way with our d. Okay, the d stays on the denominator. So the only thing we need to move are the variables a and c from our numerator going to our denominator. So a raised to 1. And for our c, raised to negative 2 from the denominator will be placed and moved to our numerator. Therefore, our final answer would be 2b squared c squared all over ab. And that's it. I hope after watching this video, you really learned, and please watch out for more videos to come, and I hope I still have more time to create videos. That's all for now. Keep safe mga kamasters. God bless us all. Bye-bye.